So whenever the displacement of a particle is given in an equation form, we have to derive twice to find the acceleration of a particle. I need to find velocity, acceleration as well as displacement. Displacement is given. If I differentiate it one time, I'll get the velocity. First note that volume of a sphere is 4 by 3 pi r cube. Area is 4 pi r square. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we'll be starting up with the new chapter, Application of Derivatives. In our previous session, we have learned how to derive a function, that is differential calculus. We have learned how to derive a given function. What is necessary to find out the derivative of a function? What are the applications of learning differentiation? Here we are going to learn one of the important application of learning differentiation in terms of rate measure. So then, what do you mean by rate measure? Suppose we have taken a function in the form of y is equal to f of x. We say y is depend on the variable x. So whenever the x changes, y also changes. So that is a dependency of one to each other. So rate measure is nothing but the same. If one variable depends on the another variable, then the rate of change of one variable with respect to other can be found using derivative, that is nothing but the rate measure. So one quantity changes with the other quantity. With the help of derivatives, we can find the rate of change of one quantity with respect to the other. So we'll take few examples for this. Also note that rate measure with respect to time is nothing but increase or decrease. A quantity may increase with respect to other, a quantity may decrease with respect to other. That we will find using the rate measure with the help of derivatives. If s is the displacement of a particle in time t, v is the velocity of the particle. Then v is nothing but the rate of change of displacement. So the rate of change is nothing but differentiation or a derivative. The rate of change of displacement with respect to time is nothing but change in displacement, we will write it as ds. Change in time, we will write it as dt. And velocity is nothing but the ratio of displacement with respect to time. So therefore, the rate of change of velocity is nothing but ds by dt. One more thing you should know here, whenever a body, we say with the initial velocity, the time should be 0. And whenever the body comes to rest, we assume it at the final velocity. At that time, the velocity of a body is 0. So therefore, in the initial velocity, we will consider time t is equal to 0, and in the final velocity, we consider v is equal to 0. Hence, v can be written as ds by dt. Now, let's see about the acceleration. What do you mean by an acceleration? Rate of change of velocity with respect to time, that is v by t. A change in velocity is with respect to time is given by dv by dt. But what is dv by dt? It is change of displacement with respect to time. So therefore, v is replaced by ds by dt. Hence, the acceleration can be written as d square s by dt square. So whenever the displacement of a particle is given in an equation form, we have to derive twice to find the acceleration of a particle. Next, similarly, the rate of change of area of a circle with respect to radius can be taken as dA by dr. Whenever with respect to time is given, it is dA by dt. The rate of change of volume of a sphere with respect to radius is dV by dr. With respect to time is dV by dt. Next, rate of change of temperature with respect to T, that is time. Capital T denotes change in temperature, small dt denotes change in time. So therefore, dt by dt is nothing but change of temperature with respect to time. Similarly, rate of change of price P with respect to quantity can be written as dP by dQ. So these are all few examples to know how the rate of change of one quantity varies with the other. Let us see the problems. The distance s feet travelled by a particle in time t second is given by s is equal to t cube minus 6t square plus 15t plus 2. Find when the acceleration is 0. So we have to find the time of a body whenever the acceleration is 0. So they have given acceleration as 0. We need to find the time t. Now, what is acceleration? Change in velocity. What is velocity? Change in displacement. But in terms of derivative, we have seen that acceleration can be written as d square s by dt square. That is, we have to derive the displacement with respect to time 2 times. Let's see it now. So, we have s is equal to t cube minus 6t square plus we have 15t plus 2. So therefore, ds by dt is nothing but 3t square minus 6 into 2t plus 15 into 1 plus 0. So I am deriving as per you have learnt with the respect of x only. So when you have x cube, you have written in the form of 3x square 2x, derivative of x 1. So therefore, there you are deriving x with respect to x. Since you are deriving t with respect to t, so it must be same as you have learned for x. Now derivation of any constant is 0. So what is ds by dt? So ds by dt is 3t square minus 12t plus 15. Now let us derive it again because I need the second order derivative. So d square is by dt square. So this can be written as 3 into 2t minus 12 plus 0. So therefore, ds square s by dt square is nothing but 6t minus 12. What is this actually? Acceleration. So let's take given acceleration is equal to 0 here. What is d square s by dt square? It is 6t minus 12. So therefore, this implies 6t is equal to 12. Hence, t is equal to 2 seconds. So, at the time t is equal to 2 seconds, the acceleration of a particle was 0. Next, if the displacement s at any time t is given by s is equal to root of 1 minus t, show that the velocity is inversely proportional to the displacement. So let's see now, here we have given s is equal to root of 1 minus t. We should show that the velocity is inversely, inverse means they should be inverse to each other, inversely proportional to the displacement of a body. So let's see now, we know v is nothing but change in displacement. So let us derive this root of 1 minus t. Suppose you have root x as a function, then you would have written dy by dx as 1 by 2 root x. So similarly, you have root of 1 minus t. So derivative of s with respect to t becomes 1 by 2 root 1 minus t. Again, you have to differentiate because 1 minus t is also one more function. It is not only t, it is 1 minus t. So using chain rule, we have to derive it again. I'll take v here. So 1 by 2 root 1 minus t. Differentiation of 1 is 0. Differentiation of t is 1. Since you have minus, it becomes minus 1. Now we have got v is equal to minus 1 by 2 into 1 by root of 1 minus t. What is this root of 1 minus t? It is nothing but s. So v is equal to minus half into 1 by s. Now I'll take, let k is equal to some proportionality constant. So this implies v is inversely proportional to 1 by s. So if I remove the equality with the proportionality constant, if I remove inequality, I'll get the proportionality. So there I'll get V is inversely proportional to 1 by s. Hence, we have proved this. Next, the displacement S of a particle at time t is given by S is equal to 2t cube minus 5t square plus 5t minus 3. Find the time when the acceleration is 14 feet second square, the velocity of a displacement at that time. So here the displacement of a particle is given. S is equal to 2t cube minus 5t square plus 4t minus 3. I need to find the time when the acceleration is 14 second square and the velocity and displacement when you know the time. So let us calculate the time first. So we have S is equal to 2t cube minus 5t square plus 4t minus 3. I need to find velocity, acceleration as well as displacement. Displacement is given. If I differentiate it one time, I'll get the velocity because velocity is change in displacement. So differentiate t cube, it is 3t square minus 5, 2t plus 4. So therefore, V is equal to 6t square minus 10t plus 4. Now let us differentiate this again. So that is nothing but acceleration. Acceleration is d square s by dt square. So let us derive this again. So 6 into 2t minus 10. So therefore acceleration you will get it as 12t minus 10. Because d square s by dt square is nothing but acceleration. Now they have given acceleration is 14 feet second square. So for the first question it is 14 is equal to 12t minus 10. 12t is equal to 24. So therefore we get t is equal to 2 seconds. Now we got time t is equal to 2 seconds. Let us calculate the velocity and displacement. We have here velocity and displacement. Velocity V is equal to 6t square minus 10t plus 4. So at time 2, it is 6 into 2 square minus 10 into 2 plus 4. So which is 24 minus 20 plus 4. Velocity is equal to 8. So what is given? Feet per second. So this is the velocity. Next, let us take the displacement. So displacement is 2t cube minus 5t square plus 4t minus 3. So S is equal to 2t cube minus 4t square plus 4t minus 3. So it is 2 into 2 cube minus 5 into 2 square plus 4 into 2 minus 3. So it is 16 minus 20 plus 8 minus 3. That is equal to, so 1, we will write it as feet. So the displacement of a particle is 1 feet at the time t is equal to 2 seconds. Next, when brakes are applied to a moving car, the car travels a distance s feet in t seconds, given by s is equal to 20t minus 40t square. When and where does the car stops? Now, we have to find the time of a particle. Also, where does it stop? Whenever the brakes are applied to a moving car. So, while a car is moving with certain velocity, when you stop the car, it reaches the final velocity. For the final velocity, we take v is equal to 0. So, therefore, here displacement is given as 20t minus 40t square. Let us find v. V is nothing but ds by dt. Here when you derive t, you will get 20. Here when you derive t square, you will get 2t. 2 into 40 is 80t. Now since the car stops, v becomes 0. So we are left with 20 minus 80t. So this implies 80t is equal to 20, or t is equal to 20 by 80. When you cancel it, you will get 1 by 4 seconds. Or you can write t is equal to 0.25 seconds. So they have asked you, when does the car stops? So therefore, the car stops after 0.25 seconds. Also, we need to find out where does the car stops. Since we know the displacement, now S is equal to 20t minus 40t square. So substitute 0.25, or t is equal to 1 by 4 form only. So it is 20 into 1 by 4 minus 40 into 1 by 4 means 1 by 16. So here solving this, 5 minus, so 2.5. So therefore, S is equal to 2.5. Now S is given in terms of feet. So therefore, we will write it as feet. So it stops at a distance of 2.5 feet after 0.25 seconds. Next question. A particle moves according to the laws S is equal to tq plus at square plus bt. Find A and B if the initial velocity is 5 unit, and when t is equal to 1 second, it is moving with a velocity which is 4 times the initial velocity. Now, a particle is moving at a displacement S is equal to tq plus at square plus bt. They have given the initial velocity is 5 units. Let's find the velocity. Velocity is nothing but change in displacement. So we will derive it. This is 3t square. T square is 2t. When you multiply with a, it is 2at. And derivative of t is 1. So this is the velocity. Now, we have got v is equal to 3t square plus 2at plus b. In the first case, they have given the initial velocity is 5. So phi is equal to time for the initial velocity. Whenever you have an initial velocity, we take t is equal to 0. So this is 0 plus 2a, 0 plus b. So from this, we get b is equal to 5. What is the reason? Since time is equal to 0 for the initial velocity. Next, in the second case, they told when time is equal to 1 second, the velocity of a body is 4 times the initial velocity. So that means v is equal to 4 times the initial velocity, means it is 20 when t is equal to 1. So let us substitute. So it is 20 for this equation. 3 into 1 square is 1 plus 2a plus b, we got it as 5. So now 20 minus 8, we get 2a is equal to 12. So therefore, the value of a is 6. Hence, the value of a is 6 and the value of b is 5. Next question. The radius of a circular plate increase at the rate 8 by 3 pi centimeter per second. Find the rate of change in the area when the diameter is 12 centimeter. Also find the rate of increase of circumference of a circle after 3 seconds. So here we need to know about the area of a circle, that is pi r square, circumference of a circle 2 pi r, and we need to know that diameter is 2 times the radius. First, let us calculate the change of area whenever diameter is 12 centimeter. So they have given dr by dt, change of radius with respect to time, that is 8 by 3 pi centimeter per second. Now for the first one, we know area is equal to pi r square. So change in area with respect to time is pi into r square, means 2 into r, with respect to time means dr by dt. So the quantity differs here. Radius with respect to time means it must be dr by dt. Now here we have pi, 2r is nothing but the diameter. and diameter is given as 12 centimeter. So here 2r is equal to 12. So therefore here 12 into 8 divided by 3 pi. Pi get cancels, 3 ones are 3 fours are. So therefore it is dA by dt is equal to 32 centimeter square per second. So change in area is always in terms of square units. So centimeter square per second. Here we have find the rate of increase of circumference. So that is, we know C is equal to 2 pi r. So dC by dt is nothing but 2 pi into dr by dt. So dC by dt is 2 pi into 8 by 3 pi. So cancels, here we will get 16 by 3 centimeter per second. So this is the change in circumference, 16 by 3 centimeter per second. Next, the volume of a sphere is increasing at the rate of 4 pi cubic centimeter per second. Find the rate at which the area of its surface increases when its radius is 10 centimeter. So they have given volume of a sphere changes, that is dV by dt. Change in volume is 4 pi cubic centimeter per second. We need to calculate the change in area whenever radius is equal to 10 centimeter. First note that volume of a sphere is 4 by 3 pi r cube. Area is 4 pi r square. Now let's calculate the change in volume, which we have given dV by dt is equal to 4 by 3 pi. When you derive r cube, it is 3r square into dr by dt. 3 we can cancel. dV by dt is given as 4 pi. So 4 pi r square into dr by dt. Again we can cancel 4 pi. R is given as 10 square. So here this implies dr by dt is equal to 1 by r square, which is nothing but 1 by 10 square. So therefore change in radius is 1 by 100 centimeter per second. Next let us calculate the area. So area is 4 pi r square. Change in area is dA by dt is equal to 4 pi into 2r into dr by dt. Now 4 pi into 2 into 10 into 1 by 100. Cancels, 10 ones are, 10 tens are, 2 ones are, 2 fives are. So we are left with 4 by pi 5. 4 pi by 5. Since it is area, it is centimeter square per second. So this is the change in area of the sphere when the radius is 10 centimeter. Like this, we are finding the change of one quantity with respect to other using certain conditions. We will solve few more problems in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.